Hi everyone, in this video we discuss about further more algorithms which are used to implement a rate limiter. Video in which we are going to discuss few other algorithms to implement a rate limiter. So in this, let's say the first algorithm which we are going to discuss is fixed window counter algorithm. So what we actually do in this algorithm is like, first we divide our timeline into fixed windows of particular time. Second, we have a counter for each window. So let's say this is my timeline and I divide my timeline into windows of 1 minute. So this is suppose 12:00, this is 12:01, 12:02, not to scale, 12:03 and this. So we have a counter for each window. So what does the counter denote is, whenever a request comes, the counter value is increased. We do a counter plus 1. And whenever this counter, let's say counter is greater than a threshold value which is predefined, whenever this counter is greater than the threshold value, request dropped. So let's understand this with an example. This is a pretty simple algorithm, so you can understand very well. So like, this is a timeline. I have a window size of 1 minute. This is 1 minute window size. I have a predefined rate, like let's say 3 requests per minute is allowed, and this is how I divide. So let's say this is 100, 101, 102, 103. So suppose first request 1 comes, counter is, initially counter was 0, first request comes, counter 1, second request comes, counter 2, third request comes, count equals to 3. Let's suppose another request comes. Now count equals to 4, which is greater than our predefined rate. So this is dropped. Mind you, now suppose another request comes, but it is here. Will this be, so in this case what we do is, the counter is, whenever we are moving from one window to another, the counter is reinitialized to its initial value, which is 0. So whenever request 5 comes, so counter will again count back to 0 plus 1, which is 1, and again it will move forward by implementing this logic. So this is fixed window counter algorithm. So what are the pros of this algorithm? So if I write down, so as you can see, this is very easy to implement, or rather this is memory efficient. It's easy to implement. What is the cons? So here one use case might arise. Let's understand this by an example. So our count window size again is like say 1 minute, rate is 3 requests per minute. Okay, now let's say this is 101, 101, 102. Okay, now let's consider 3 requests arise here. Okay, so let's say R1 to R3 arise here. Counter is 3, all of them passes. All of this pass. Again, let's say when it's just past 101, counter is reinitialized or reset, counter is again 0, again 3 requests comes. And these are, since counter is again 3 less than our threshold, less than equals to our rate, so these are also passed by our rate limiter to the API server. Let's say this time frame is 101:30 and this is 100:30. So this is again a 1 minute time frame. So just notice, in a single minute time frame our predefined rate was 3 requests per minute, but here actually 6 requests are forwarded, which is double the permissible limit. So this is one of the drawback of fixed window counter algorithm. So we can write, like, one of the cons is spike in traffic at edges of the window. This causes more number of permissible requests to be forwarded to the API server. So in order to fix this drawback of this algorithm, we will now see another algorithm which deals with this issue and fixes this issue. So this is called sliding window log algorithm. Sliding window log algorithm. So what happens in this algorithm is, we have a rate limiter, let's say, where we, whenever a request comes, let's say at a particular time it has come, we log that timestamp inside the rate limiter. So suppose request R1 comes at 101, so we 10 and we log this, and it has also a predefined rate. Let's say it will allow 2 requests per minute. So now suppose R2 comes. Firstly it comes at, let's say, 100,105. Firstly we do is we log that timestamp whenever a request comes. Now we check if how many requests are there in a time interval starting from here in 1 minute prior to that. Okay, so here we see that from 1005 till previous 1 minute there are 2 requests, so this request will be passed. Now suppose another request comes, it comes at, let's say, 100,300. Remember, whenever a request comes, it is being its timestamp is logged into the rate limiter. Now let's say this has come. So starting from this time till previous 1 minute, it will check how many requests are there. So starting from this time, previous 1 minute will be, let's say, 12:30 and all. So we will calculate the time. We check this falls within that 1 minute, this falls within that 1 minute. So 2 requests are already being forwarded. And our predefined rate was 2 requests per minute. So this request will eventually be dropped. So this is dropped. But remember that timestamp has been logged into the rate limiter. This is already present. Now suppose, let's say, another request comes, R4, and the timestamp it has come is 102. As I had earlier said, we will log this timestamp first. Then starting from this time, we will check what are the permissible records which are present within 1 minute timestamp. So we check till 101, from 101 to 102. We will check if there are any records, and if there are any records prior to this with older timestamp, those are removed from the rate limiter. So now this will be removed. This timestamp will be removed from the rate limiter. This is removed. This is also removed, since all these fall before 101. And now, since after those are removed, I will check the number of requests which are currently present in this particular timestamp. So this is 1, and since this is present, so this will be forwarded to our server. This will be forwarded. So what has happened is, like, if we just write down the steps, what we do in this algorithm is, first request comes, log the timestamp. Now from this time till your defined rate time, right? So in this case it was 2 requests per minute. It can be 2 requests per second, so I will consider for our case it is 1 minute. So from this time till your defined time, calculate the number of requests. We will say remove the older timestamps which are before 1 minute. From our current requests timestamp. Right. So now we have counted the number of requests, and if the number of requests which we have counted earlier is less than our threshold, which we define like 2 requests per minute, we will allow this request. Else drop. So this is our sliding window log algorithm. So whenever first time a request comes, we will log the timestamp no matter what happens. Either the request is dropped, either the request is forwarded, the timestamp remains in the rate limiter. Now from this time till our predefined rate time, like 2 requests per minute or 2 requests per second or whatever you have defined as per your use case, we will check that time, and all the previous timestamps prior to that are removed from the rate limiter. And now after we count the number of requests we have encountered till now, if that request is less than the threshold, and upon adding this request we do not increase the threshold, we do not go beyond the threshold, we can forward this request, or else the request is dropped. So this is our sliding window log algorithm. So what is the pros of this algorithm? This is a very efficient algorithm. So one of the greatest pros is like this is a very much accurate algorithm. No excess requests forwarded, just like we saw in the fixed window counter algorithm. Some excess requests were being forwarded in the edges of the windows, but here no excess requests are forwarded. And one of the cons is like, as you have seen, even though a request is dropped, its timestamp has been logged into the rate limiter. So memory, this algorithm uses memory since the timestamp is stored. So this is the overall sliding window log algorithm. So it's very much efficient and no excess requests are forwarded. It's very much accurate, but it uses a lot of memory since the timestamps are recorded in the rate limiter, be it the request has been forwarded or dropped. Okay. So now let's look into the final algorithm of this series of designing a rate limiter, which is sliding window counter algorithm. So from the name you can guess that this is a hybrid of the two earlier algorithms which we just discussed, is fixed window counter and sliding window log. So let's understand this algorithm with the help of an example. Say, suppose I have a timeline and this is suppose our timestamp which we are considering, and this is here. Yep. We define a rate, let's say 5 requests per minute is our rate at which we allow the requests to be forwarded. Now suppose at this time, which is let's say 1:20, a request comes. So from this time onwards, we will create a rolling window of 1 minute from here. We create a rolling window. So this time is 1:00:20. So this rolling window of 1 minute, since we have considered our time frame to be of 1 minute each. Now let's define a few terms. So from this time 1:01:20 till our previous window's time, this time is called, or this window is called current window. And this window from our previous window's time till our rolling window's starting time we call as previous window. And let's say in our previous minute, this is previous minute 1:01 to 1:00. In this previous minute there are a number of requests which has come. Okay. And among them 4 requests are inside this previous window. So this algorithm is based on approximation. What do we approximate? We approximate the number of requests which are forwarded till now. So till now means whenever we encounter a new request. So for this R1 number of requests, we will first calculate the number of requests which are forwarded till now. So to calculate the number of requests forwarded till now, we use a formula. Number of requests forwarded is equal to number of current requests in current window plus number of requests in previous window weighted to the contribution of previous window. Right. So what do we mean by the contribution? So in this entire time frame 10020 to 10120, and from this previous Windows end time, which is 101. So we see here it's 20 second and here it's 40 second, which entirely sums up to 1 minute. So the contribution of the current window you can calculate is like 20 upon 60 into 100, which sums up to be approx 33, and the remaining this contribution is 67. So in this way we can calculate the contribution of individual windows. So now getting the figures, so let's say here initially there was another request R0 which was present. So one request was already present in the current window plus number of requests in the previous window. How many requests are there in the previous window? It's like R3, R4, R6, R5. So it's 4. And what is the contribution? So contribution is 0.67. So if I calculate, so this comes down to be 1 plus 2.68. I hope this is correct. Yes, and to total 3.68. Now let's round off to a higher number. So this is 4. So number of requests forwarded till now is 4. Remember our rate was 5 requests per minute. Okay. So since it's 4, another request R1 has come, it makes it to 5, and since this is less than 5, number of requests forwarded is now 5. So R1 is forwarded. So R1 also goes into this and it is forwarded. So did you see what happened from this approximation? From this approximation, we see actual number of requests which are forwarded is like 1, 2, 3, 4, 5, 6. But since we only calculated the contribution of the previous window, so we had actually moved forward from our mathematical calculation 5 requests. But in the actual time, we have moved forward 6 requests. So this is one of the drawbacks. So you can say cons is like, since it's an approximation algorithm, it works on not so strict look back. Actually, this is an approximation of the actual rate because it assumes requests in the previous window are evenly distributed. So it assumes requests are evenly distributed in previous window. However, this seems to be not an major issue in a real world scenario, because an experiment done by Cloudflare shows that only 0.003% of the requests are wrongly allowed or rate limited among 400 million requests. So this handles the, so if you look at the pros, it's first of all is memory efficient, and in the fixed window counter we saw a large number of requests, or rather double the number of permissible requests are forwarded in the edges of the window. But in this case it smoothly handles the spike in traffic by its approximation approach, or rather averaging out. or averaging out the requests. So in this way it handles the spikes in the request which we saw in the fixed window counter near the edges of the window. Yeah, so I hope you understand these algorithms. So now we have we have discussed all the algorithms by which we can implement a rate limiter. I'll attach some references for you to read further regarding these algorithms. If you're interested how they are actually implemented in code, you can check the description box for this. Next, we will look into an high level architecture, how this rate limiter is actually implemented in our particular scenario, in a real world scenario. So thank you for watching this video. See you in the next video.